All right, guys, welcome back to another KevCam night class tonight. Tonight, we are going to finish off where we left off using that part for the Swiss screw machine on the Citizen. If I kind of breeze through this stuff a little fast, it's because I've already done this once, and I accidentally forgot to hit the record button when we did the night class live, so doing this after the fact. But with that being said, we'll get the ball rolling here and start where we finished off from last week. So last week what we did is we set up our MCO to kind of set up our machine here, and like I said before, these MCOs are pre-written for you guys by the post processor. And so what we're doing is kind of setting the machine 0 here, doing some outside contours, doing a couple more MCOs to align the B-axis, and let's just do a quick simulation here and kind of show you what things are looking like. So we'll do a, let's do a solid verify first here. So far we faced it off, and we're doing the OD turn here. Doing a finishing, doing our drilling, and we're doing our threading now. And now we're doing our live tooling on that front face here and drilling our holes. Now let's take a peek and see what that looks like in Machine Sim, just to kind of get you guys up if you guys are forgetting from last week. All right, now we have our Machine Sim pulled up in here. I'll kind of get everything. So here's our main spindle that we're working on. Here's our tool number 1. And all the tools are labeled in the Machine Sim for you guys, kind of like I mentioned last week. So we got main spindle over here, sub spindle over here. With this Machine Sim, you will have the full ability to show the entire machine itself. We can do a transparent, or we can just get rid of everything there. So let's kind of zoom in here and see what we did so far. So we're facing off the part, doing the OD turn. Finishing the OD turn, doing our drilling, now we're doing our threading, and now we're doing our live tooling. Doing a reposition here. And I got it going really slow right now just so you guys can get a good view of exactly what's going on. And doing our face drilling. So that's where we left off. So now we need to finish some more stuff on this part on the main spindle. So what I'm going to do is I'm going to start off with first doing these flats up here. So now what I'll need to do is create a coordinate system that Z is perpendicular to that face. And technically I would want to create 3 of them because I have 3 of those flats. But what we'll actually do here is save us a little time, is we'll create one operation and then we'll actually transform that around. So we'll just go and just do a quick pocketing operation here. And then since I need to create a new coordinate system, I can go over here and add one, or I can just click on the coordinate system button right here. And we'll just do add. And what I'm going to do is keep it relative to coordinate sys 1. And all I have to do is just click on that top face, and it will align my Z-axis with that face right there. So I'm going to flip around to get my X-axis going in the right direction. Hit OK. And now we can start grabbing our pocket geometry. So I'm just going to use the Smart Face technology and just click on that face. We'll go ahead and grab our tool here. And I'm going to be pulling the live tooling from the B-axis head, which is going to be my tool number 13 here. And levels. Just as a quick sanity check, like I said before, is when you're picking your levels, just grab a couple different spots there just to make sure that number's not changing. If that number's changing, that means our Z is not perpendicular to that surface. So we want to make sure that number is coming up the same no matter where we click. And since we are using pocketing, it knows that it just needs to do one pass to make it through. So let's go ahead and take a quick preview of what we're doing here. So we just machined that one flat. We'll just do a quick sanity check. So we're yellow, so we're right up to size, which looks good. Now, like I said before, is we have to have a coordinate system for each rotation, but what we can take advantage of is the transform feature inside SolidCAM. And we will do 4-axis, and we'll do include original. And since we have 3 of these faces, 360 divided by 3 is going to be 120. And we'll insert 2 additional in there, and you can see it projects it around for us. So get a kind of better view for you guys. Hit OK. Save. And we'll do a quick simulate here and do a solid verify. And let's do a quick check. Yep, everything looks good. We're yellow all the way around. Let's check this side real quick, and that's yellow. So we're good to go. So since we're already kind of working along that, doing those flat parts right there, we'll go ahead and do the drilling for those. So we'll go ahead and pick drilling here. And pretty much the same thing as what we've done before. New geometry. Grab that face. Grab our tool here. And that's going to be that on that same tool area as before. So we want to use our live tooling, which is going to be our tool number 12 here, which is a 0.118 drill. Levels, kind of like I said before, upper level, just go ahead and click around. Since we already did our milling, we know our coordinate system is good. And now what I'm going to do here is navigate and get our point. So our numbers have updated, and we'll just do a straight drill. So we can just do save and calculate. I got my feed rate a little too high here. So just bump this down. Save and calculate. And let's go ahead and do a simulate real quick. There we go. So we got our drill hole there. So now we'll do that exact same thing as what we did with the milling, is we'll do the transform. So we'll do 4-axis, include original, 120 degrees. And you see we drilled all the way around. So let's go ahead and play both of these operations through in MachineSim just to make sure everything's 100%. All right, so now get orientated around here, and we'll go ahead and play this through. Does the one flat, another flat, and does it go pretty quick on these flats, and doing our drill, and our final drill there. So we are looking good. So now what we can do is let's go ahead and mill off our flat right up here. So for that particular one, what we're going to want to do is another pocketing operation. And we're going to need to create another coordinate system just for that, so the Z is pointing in the correct direction. So we'll just go ahead and click on CoordSys and add. And we're relative to CoordSys 1, so I'll just grab that face right there, orientate my X and Y's, accept that. And now I'm going to do mark open edges here. And the reason it didn't automatically mark these as open is if you look right here, here's my wireframe of my stock. I didn't turn it down to size, so that's why it's not marking these as open. So I'll just come in here and right there. And for our flat, we will be using our live tooling again on our B-axis. Levels. And like I like to do is just click around just to make sure that number is not changing. Looks good. Save and calculate. And let's go ahead and simulate this. And let's just make sure we're up to size here. So we're showing yellow, which is excellent. And let's just see what it looks like in Machine Sim for you guys. All right, so we got our Machine Sim pulled up here. And let's go ahead and play this through. This is using our live tooling down here on our B-axis head. Now we could do this exact same operation using tool number 6 right up here as well. So a couple different ways of going about that for you guys. Now we'll actually use that in a different scenario when we go to program this wrap functionality. Okay, so we got our flats right here, machine now, and now we just need to drill those holes. So we'll go ahead and do drilling. And we're going to be using that same position. And I can just click on that face. And that should grab our holes, yep. And for this one, we are going to use the live tooling that's right above the spindle. And that's just to accommodate because that's where the drill, that size drill is actually being located right now. All right, so upper level, it's going to be right here. Lower level, we're going to drill down to that point, save and calculate, and that ding feed rate got me again. So let's bump this just to 8, save and calculate, do solid verify here, and we're right on size, so we're good to go. Okay, so now that we got those done, I'm going to go ahead and turn off all my wireframe of what's going on here. What we're going to focus on now is the other side of this part. And this is where we're going to use that live tooling that is right above the spindle. So we'll do a pocket right here. And for this one, since we are going to be wrapping the geometry, we'll just use Mach 1, position 1 here. And what we're going to do is do a wrap around the Z-axis. And make sure you always grab that wrap first before you grab your geometry. And do our auto chain. And we'll go ahead and grab our tool. And with levels, doesn't matter where you click, just click on the outermost diameter and the innermost diameter, and that's going to populate our numbers for us. And since we told it it's being a wrapped functionality, it knows that it's basically going to revolve everything that is going on there. So just click on somewhere on the outside diameter and where you want to mill down to, and it's going to do the calculation for you guys. So we just do save and calculate here. And let's do simulate, solid verify. And there we go. So that tool is a little bit large for what we're doing. So what I'm going to do is just make a copy of what we just did and then just switch it over to a smaller tool. So we were using tool number 13, which is a 1/4 inch, and now I'm actually going to use a smaller tool on tool number 6. And this is actually going to be coming from the B-axis head here. And level should be set, so we'll just do save and calculate. Do solid verify. Just cleaning up our corners there. And this is also kind of testing the functionality of the machine to make sure everything is good on the machine. So let's go ahead and play this through on the machine sim here. All right, we got our machine sim pulled up. You can see our other operation has been done. And let's go ahead and play this. Looks good. Okay, so now that we got our wrap functionality, we're basically done with everything on the main spindle itself. So what we need to do now is get everything kind of set up for transitioning this part over to the sub spindle. So what we're actually going to be doing here is we're going to get everything kind of ready for the cutoff. And this is all kind of done with your MCO. So all you have to do is come up and do a add machine control operation, which is our MCO. And what we want to do first is get our main spindle positioned for cutoff. So this is going to be our Z1, and how Daniel labeled these as Z1 is your main spindle, Z2 is your sub spindle. So we're kind of getting everything positioned for our cutoff right there. So let's do save and calculate, and we can hop out of there. Now what I want to do now is I want to get the sub spindle aligned up for it to do a parts catch. And basically, you know, our main spindle is doing the first half and our sub spindle is going to be doing the second half. And what we have to do is program it as if our second half is already done. So we'll do another MCO here. And for this one, we are going to do our sub spindle parts catch. And get it get it positioned for the parts catch. And so basically what's going on here is, like I said, this is all set up with your guys' post, but we're telling it to position over to the location. It's going to set up the clamp. It is going to turn on through spindle air blast, and then it's going to unclamp and drop right into the parts catch. So we'll just do save and calculate on that. So now what we want to do is, now that that sub spindle has moved over to drop that part out, now what we want to do is align our sub spindle with our main spindle. And the reason we want to do that is that sub spindle is going to come over right on location over here and clamp on the part synchronized with the main spindle. So for that, we're going to do another MCO. And we want to do a sub spindle and main spindle sync. So we're going to do Z1, Z2, synchronization on. So we're basically aligning our sub spindle with our main spindle. All right, so now that we have our sub spindle and main spindle synchronized and clamping on with each other, now we can do our part cutoff. So what we'll do is just a simple solid cam turning and part cutoff. Grab our geometry here, and I'm going to do a modify and auto extend it first to compensate for a stock. And grab tool number 1, because that's always our cutoff tool with the Swiss machines. And levels are good, technology looks good. Save and calculate. And let's go ahead and see what this looks like. So turning, and I just want to make sure I'm cutting on the right side. Yep, looks good. Perfect. So now we have that sub spindle clamped on here along with the main spindle, and everything's grabbed onto. So now what we want to do is kind of do end that program along with the bar change. So it's going to shoot out the bar. So we'll do another MCO for that. And we're going to do program end with bar change. Save and calculate here. And now what we want to do is tell that sub spindle to go back to its home position or its reference position. So for that, we'll just do another MCO here. And we want to do Z2 home position, or actually Z2 part move after cutoff. So basically that sub spindle is going to go back to its reference point after it's been cut off. And by doing this, it's telling SolidCAM that now that the sub spindle has the remaining stock of this part that we still have to do. So now, last thing we need to do is unsynchronize both of these spindles. So for that, we can just do another MCO here, and we can say Z1, Z2 unsync, synchronization off. And that's just basically telling it now the sub spindle and the main spindle can do different speeds and feeds and so on and so forth. So just do save and calculate there. So let's just kind of play through what we just did here. Now this looks like a lot what I just did here, but this is once you guys have this set up in your tree, what you guys can do going forward with any part is just highlight these operations and create this as a template. So when you bring this in to do a part transfer, it's going to include all of the correct MCOs. It's going to do your cutoff for you. The only thing that you will have to do is go in there and just add that line in there for your geometry. So kind of giving a overview is we're just getting the sub spindle ready for cutoff, and then we're going to position the sub spindle for the parts catch, and then we're going to get rid of that part in the sub spindle, and we are going to take that sub spindle, reposition it over to where the main spindle and the sub spindle are lined up and they're synchronized together. We're going to cut the part off, and then what's going to happen is that part is going to clamp and just move a little bit out of the way and advance forward the stock for the new part from the bar feeder. And then the sub spindle is going to move back to its reference position, and then they are going to unsync from each other so they can go back into their independent ways. So let's go ahead and do a simulate, and we'll do a machine sim on this one. All right, so we got our machine and kind of get a good view of what's going on here. It's going to go pretty quick here, but play it. Clamps on, part cut off, and goes back to its home reference point. So pretty simple, easy. And like I said last week, you know, the Swiss is, you talk about Swiss and so, oh man, this is going to be a whole new animal. This is all stuff that we've previously covered in your mill turn and your turning. The only difference with the Swiss is just having these MCO cycles in here, which is already predefined for you guys by the post processor. So from right there, we are ready to start doing the work on the sub spindle. And we'll actually start that next week on the sub spindle and get everything done on the sub spindle. And then the last class we'll do is the channel synchronization, get everything to mesh together. So it's going to be a like I said, this is a little bit of a shorter class just because this is the second time doing it, just because I forgot to hit the record button prior. But this way you guys up on YouTube can see what's going on there. One thing is I would like to get your guys' feedback on hotkeys. We're really trying to add as many hotkeys in there as possible. Now we do have hotkeys for chaining, but other than that, we really don't have too many hotkeys, and our CTO would like to get your guys' take on what you guys would like to see hotkeys. So if you guys could email me, and my email is in the comment section below, of hotkeys that you would like to see. Most popular one that I can think of is a Save and Calculate hotkey and a Simulate hotkey. But if you guys have other ones that you would like to see added in there, please email that to me, and so we can get that added in there for 19 as well. So, all right, I'll leave you guys off there. Thanks, guys, and have a great, wonderful night. And if I don't talk to you in the meantime, we will talk to you guys next week to finish up the turning and the live tooling for the sub spindle. All right, guys, have a great evening. Bye-bye.